Hello. Hello and welcome to this 24th set of problems on quadratic equations and polynomials. So first of all, I'll tell you how to get the PDF. I tell this in every video. Go to astavakar.org, click this second link and you will have the PDF. You can click this save button to download it. Okay. And the date here will represent the fact that it has been updated on this particular date. I have changed the PDF but I have not uploaded it since the last video. So with that out of the way, let's go through the problems. Question 231 says that if alpha and beta be the values of x obtained from the equation m square into x square minus x plus 2mx plus 3 is equal to 0, and if m1 and m2 be the two values of m for which alpha and beta are connected by the relation alpha by beta plus beta by alpha is equal to 4 by 3, find the value of m1 square by m2 plus m2 square by m1. Let me send this in full screen. Okay. All right. So we have the equation, we rewrite it. We have now m square x square plus 2m minus m square into x plus 3 is equal to 0. Now alpha beta are the roots, so sum is given by minus 2m minus m square by m square, which is m minus 2 by m, and product of roots alpha beta is given by 3 by m square. Now it is given that alpha by beta plus beta by alpha is equal to 4 by 3. That is 3 into alpha square plus beta square is equal to 4 alpha beta. We write left hand side alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta, which gives us 3 into alpha plus beta whole square minus 10 alpha beta is equal to 0. Now we plug in the value of alpha plus beta and alpha beta, and we do a bit of calculation to arrive at m square minus 4m minus 6 is equal to 0. Now this will give us m1 and m2. So sum of m1 and m2 is 4 and product is minus 6. Now we have to evaluate m1 square by m2 plus m2 square by m1, that is m1 cube plus m2 cube by m1 m2. So we rewrite this as m1 plus m2 whole cube minus 3m1 m2 into m1 plus m2 by 3m1 m2, which is, if you calculate, is minus 68 by 3. Now we move on to question 232. If the ratio of the roots of the equation x square plus bx plus c is equal to 0 be equal to the roots of the equation a1 x square plus b1 x plus c1 is equal to 0, prove that b by b1 whole square is equal to ca by c1 a1. So we let the roots of first equation be alpha beta and gamma delta of the second one. So we have the typical formula for sum of the roots and product of the roots. Now according to question, the ratios are equal, that is alpha by beta is equal to gamma by delta. We do componendo and dividendo. You get alpha minus beta by alpha plus beta is equal to gamma minus delta by gamma plus delta. And we rewrite this as alpha plus beta whole square minus 4 alpha beta. This wouldn't be beta square, it is alpha beta. The square is a typo. Divided by alpha plus beta whole square. This square should have come here. Okay, so there is a typo. This square is not here. Okay, and the second equation would be gamma plus delta whole square minus 4 gamma delta by gamma plus delta whole square. We substitute the value and we solve. We get minus 4 AC B1 square is equal to minus 4 A1 C1 B square. And from that we get B by B1 whole square is equal to AC by A1 C1. Question 232 has a typing mistake. All right. Question 233 says that find the quadratic equation It's again a typing mistake or bad autocomplete. Find the quadratic equation with the rational coefficients, one of whose roots is 1 by 2 plus square root of 5. So it is an irrational root, the other root would be its conjugate. Now we let alpha is 1 by 2 plus root 5, so that its value after rationalization is minus 2 plus root 5. So the second root would be minus 2 minus root 5. Okay, minus 2 minus root 5. It's a typing mistake again here because it would be the same root. So alpha plus beta is root 5 cancelled, minus 2 minus 2 minus 4, and you multiply them, you get 4 minus 5, that is minus 1. So the quadratic equation would be x square plus 4x minus 1 is equal to 0, because this is how you write a quadratic equation whose roots are alpha beta. Now we move on to question 234. If alpha and beta be the roots of the equation x square plus bx plus c is equal to 0, again it is quantity. Find the quadratic equation whose roots are 1 by a alpha plus b and 1 by alpha beta minus alpha beta plus b. So we have alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Now sum of the roots for which the quadratic equation is to be found is given by 1 by a alpha plus b plus 1 by a beta plus b. We take LCM and then we simplify and we find this is equal to b by ac. And similarly, we do the same for product, we find this is equal to 1 by ac. And therefore the equation would be x square minus bx by ac plus 1 by ac, that is ac x square minus bx plus 1 is equal to 0. Now question 235 says that if CD are the roots of the equation x minus a into x minus b is equal to k, show that AB are the roots of the equation x minus c into x minus d plus k is equal to 0. Okay. So we have this given equation x square minus a plus b into x plus ab minus k. Now since CD are the roots of the equation, c plus d is equal to a plus b and cd is equal to ab minus k. So AB will become CD plus K, okay, and A plus B is C plus D. So the equation whose roots are A and B would be given by x square minus A plus B into x plus AB. So we plug in the values of A plus B and A plus B and AB, we get this equation as our required equation, which is this. Question 236 is that the coefficient of x in the equation x square plus bx plus q is equal to 0 was wrongly written as 17 in place of 13 and roots were found to be minus 2 and minus 15. Find the roots of the correct equation. So correct equation is x square plus 13x plus q and incorrect equation is x square plus 17x plus q is equal to 0. So roots of the correct equation are incorrect equation are minus 2 and 15, thus q is equal to 30. Now we plug the value of 30 from this equation to this equation, okay? So it will become x square plus 13x plus 30 is equal to 0. And thus roots are minus 3 and minus 10. So the question you could ask is, this is our correct equation, okay? Let me see this. All right. Was wrongly written. The x is wrongly written. Coefficient of x is wrongly written. Q is correct. Okay. So the first thing it says is coefficient of x is written incorrectly, but q is correct. So the product of roots in this case is correct. So q will be common in both the equation. That's why we have written those as q. Because if q were incorrect, we cannot write q here. The question says only that the coefficient of x is incorrectly written. And that's how we arrive at the solution. Question 237 says that if alpha and beta be the roots of the equation x square plus px plus q is equal to 0, show that alpha by beta is the root of the equation qx square minus p square minus 2q into x plus q is equal to 0. So we have sum of the roots alpha beta as minus p and alpha beta is equal to q. Now given that x is equal to alpha beta, we plug this in the equation which we have to find, and we arrive at q into alpha square minus p square minus 2q into alpha beta plus q beta square. This is one of the things. So from this, what we get is q into alpha square plus beta square is minus p square minus 2q into q. And then we further solve this and we eventually prove that 0 is equal to 0. And that's how alpha by beta is a root of the given equation. Question 238 says that x square minus x plus b is equal to 0 and x square minus px plus q is equal to 0 have a common root, and the second equation has equal roots, then show that b plus q is equal to ap by 2. So we let alpha beta to be the roots of this equation, and alpha is the common and equal root of the second equation. So what we can write is alpha plus beta is equal to a, alpha beta is equal to b from the first equation. From the second equation, 2 alpha is equal to p, alpha square is equal to q. Now b plus q, we add this alpha beta and alpha square. So alpha beta plus alpha square is equal to alpha into beta plus alpha is equal to p by 2a is equal to ap by 2. Question 239 says that if x square plus 2bx plus c is equal to 0 and a1x square plus 2b1x plus c1 is equal to 0 have a common root, and a by a1, b by b1, c by c1 are in ap, show that a1, b1, c1 are in gp. Now this is a simple question. It's not complicated, although it involves concepts of quadratic equation, arithmetic progression and geometric progression. So we have one common root. Okay, so we let alpha to be the common root, so it gives us two equations in alpha, and we do cross multiplication. We get alpha square by 2 bc1 minus b1c is equal to alpha by ca1 minus a1c is equal to 1 by 2 ab1 minus a1b. So from this equation, what we do is we compare first two sets. We get the value of alpha as this and value of alpha as this. So if you take these two, alpha will come here, this will go there. And from these two, alpha will remain here, this will go there. So there are two values we obtain, and then we equate, and we get this equation ca1 minus ac1 whole square is equal to 4 ab1 minus a1b into bc1 minus b1c. Now given that a by a1, b by b1, c by c1 are in ap, and we let d to be the common difference, then what we do is c by c1 minus a by a1 into c1 square, a1 square is equal to 4 into a by a1 minus b by b1, a1 b2 into b1 b by b1 minus c by c1 into b1 c1, and then you simply solve this problem. So once you solve this, you eventually get c1 a1 is equal to b1 square. Okay, so that's it, that's the sum. So let's talk about solving this equation a bit. Okay, you look at this equation and you see here. So we have divided and multiplied by c1 a1 to the left hand side, and from the right hand side you look at this part. We have this is not b2, this is b1, there is no b2. So we have divided and multiplied this by a1 b1, and for this one we have multiplied and divided by b1 c1. So that's how we arrive at the desired equation. Now we come to the last question of this set. If each pair of the following three equations x square plus p1x plus q1 is equal to 0, x square plus p2x plus q2 is equal to 0, x square plus p3x plus q3 is equal to 0 have exactly one common root, then show that p1 plus p2 plus p3 whole square is equal to 4 into p1 p2 plus p2 p3 plus p3 p1 minus q1 minus q2 minus q3. So since alpha is the common root, Okay, have exactly one root in common. So what we do is we say that alpha is the common root between first two, beta is the common root between last two, and gamma is the common root between the first and last equations. So alpha, beta are the roots of the first equation. So we can say that alpha plus gamma is equal to minus p1. So if you look at this, this should be gamma. Okay, this is not alpha. Gamma is the common root between first and last, and alpha is between first two. So this should be gamma. So alpha plus gamma is equal to minus p1, alpha gamma is equal to q1, and similarly we have alpha plus beta and beta plus gamma. Once we have that, what we do is we do p1 plus p2 plus p3 whole square is equal to 4 into alpha plus beta plus gamma whole square. Okay, how do we arrive at this result? That is the question. So you look at p1, okay, so it is alpha plus gamma, and beta, p2 is alpha plus beta, and beta plus gamma is p3. So if you sum them, you will get 2 into alpha plus beta plus gamma, and that when you square it becomes 4 into alpha plus beta plus gamma whole square. And right hand side, similarly, what we do, we write the values and we get, if we simplify, we get the same 4 into alpha plus beta plus gamma whole square. And that is how we prove question number 240. There are quite a bit of typing mistakes. I'll fix those. Okay. So with this, we come to the end of 24th set of problems. And I hope that you are enjoying the series and finding it useful and informative. Do not forget to subscribe to the channel if you have not subscribed till now. And like the video, share on social media, share it with your friends so that the reach of video increases. If you have questions or comments or you want videos on certain topics, make use of the comment box. So I'll see you in the next video. Thanks a lot for watching the video. Enjoy.